Hello, this is Damnesia and welcome back to another tutorial. In this tutorial we're going to go over loops. So first of all I want to start with teaching one more thing about Eclipse. Firstly, if you double click a closed project like we did from last tutorial, it opens a project, and if you right click it then you have the option to refactor. Refactor allows you to rename or move. So I just want to rename it just to show something you could do with it, and I'm going to rename it to 1 to be more consistent with the number 2 over here. I'm going to create a new project called Java Tutorial 3. Click Finish and right click it. Then I'm going to go all the way down to Close Unrelated Projects and click that. Then I can say OK. Now it's closed both projects. Next I'm going to make a new package called main and a class, once again called main. Right, so before we start with the for loops and while loops and all kinds of loops that we can get into, I want to show something from last tutorial. A few things actually. First thing is a divide. This / right here is a divide. You can use it to divide. You also have the times, which is a star. You have the plus, minus, %, otherwise known as a modulo, brackets, and brackets are basically just a way to surround parts of an expression so they can be ran first. Of course, sometimes you can just abuse the fact that Java does in fact have an order of operations to not have to do this. So those brackets can help you, but if you use them in a different place, they might even change what the actual calculation or condition is. So you need to be careful with those. Afterwards, after you've got these times, divide, plus, and minus, I'll show a way you can shorten this, but first let me just show you an integer x equals 3, integer y equals 4, and integer result equals, and for this one we're going to do 3 divided by 4, and then we're going to go ahead and output the result. Remember to put a space over here, because Java will not automatically put a space if you put a space after that. You need to make sure you put your space between these string quotations, and then you can do a plus, which is a concatenator. In other words, it just adds. In other words, what it will do is it will take this string and add this to it. Now be careful, because when you're working with integers, add also means addition. So you need to be careful when you use it. For example, if I was to do result plus x, and I put brackets around here, it would take result plus x as a calculation, and then this part will be treated as an actual string. So it will do result plus x and not result and then x put at the end of the result, as in the value of x. So for example, over here, assuming everything goes according to plan, it should say 0.75 plus and 0.75 and then a 3 at the end, so it'll be 0.753. But because we put this with brackets, it will instead say 3.75, which is the difference here. The one basically just puts the numbers as if they are letters. In other words, 0.75 and then add a 3. And if you put the brackets around it, it treats it as a calculation and it adds the two numbers. Now, what I want to show first of all is what happens when you actually do this kind of test. So you know how an integer can only actually hold a number without any decimal points. So if you run this program, we're expecting to see a result that will be kept inside an integer. So let's run this and see what happens. So this is what happens. He'll say result 3. Now you're probably wondering why. It's because of this plus x, so I'm just going to remove it quickly so it doesn't interfere with the results. And then I'm going to do this, run it again. And you'll see the result is 0. So you'll obviously think the best solution to this would be to say this is a double or a float. And then run it again. Now you see a 0.0, but it doesn't actually take into account 3 divided by 4. So why is that? Well, in Java, and in other programming languages as well, most of the time, we have something called an integer division and a floating point division. So what we did over here is we did integer 3 divided by an integer 4. So the computer will take this and do an integer division on it. And that's why we get a result of 0, because in an integer division you cannot have a remainder. So there are a few ways around this. Number one way is called a cast. Casting is basically turning something into another thing. And the spacing here doesn't matter. I'm just putting the spacing here so it makes it more obvious what's actually happening. Just going to put more spaces so it's even more obvious what's happening. So what it basically is you put in the bracket itself the data type you want to turn whatever it is into, and it will attempt to turn it into that data type. Not all conversions are possible without any kind of special code, so this doesn't work for everything. For example, you can't do this on a string, that won't work, but you can do it on an int because an int is already a number. That's why. So the reason why I put extra spaces over here is to show that this double treats this x as the target. So it basically turns this x, integer x, into a double, which is a floating point value, not to be mistaken with a float. And then the reason why I put a space is because this y over here still remains an integer if at least one of the things you're working with is a double or data type of that kind. It will convert it to that data type. And double takes precedence over integer. So when you work with an integer and a double, the other integer underneath the code also turns into a double, but you're not forcing it explicitly to be a double. So if you run this, you'll see it will actually say 0.75, which is the result we're expecting. So what happens if you want to do something like this, where you put these in brackets? Surely that should turn x and y into a double. And the result is once again 0.0. The reason is this is practically the same thing as not even putting this in at all, because it turns the entire thing into a double after the operation has already happened. So what you need to do is make sure that the operation doesn't happen before the conversion from int to double, and then it will work as you expect. And you don't have to turn the second part into a double as well, but for the sake of this tutorial I'm actually going to do that anyways. Now Java automatically does most of this, but as you can see it needs at least one data type to be explicitly turned into whatever you want it to be. So Java knows to turn the other one correctly. Next, let's go over the multiplication. Very same idea. Value is 12, as we expect. Addition. Value will be 7, as expected. -1. And finally, let's get to this right here. This hasn't been taught in the last tutorial, hasn't even been shown, but this little operator is basically a division with a remainder. What happens is the normal division over here, where you're doing this division, when you're doing an integer division, which may be what you want to do in some cases, you'll get 0 as we saw before. But there's a 0 and a remainder. In order to figure out what the remainder is, we can do this. That will give us the remainder. Basically what the remainder means is, take the value here, 0.75, although because we haven't converted it, it will actually be 0, but that's not the point. Then we do times. It will actually make it easier to understand if I put this as a larger number, like 5 divided by 4. So 5 divided by 4 is 1.25, because it's 1 1/4. So now what happens is, it basically removes anything in front of it, so it takes this part, and that will be the result of this integer division, and it practically just puts it in like this, and then multiplies it by y, which is the one you're dividing by, which is 4, and this will just equal to 1. So this entire thing will be 1 with a remainder of 1. There we go. And now if we output this, you'll see 1 remainder 1. That's basically what this means. That can be useful when you're trying to check. And the best way to check if something is divisible by 2, well actually there's actually 2 ways, but I'm only going to show this one, because the other one is using a little bit of logical operators and a little bit of Boolean algebra. But this one, the one that we use the most in programming, is this, x divided by y, the remainder of x divided by y. And what will the remainder equal to? Well, if there's no remainder, then we know that this thing divided perfectly, like 8 divided by 4. This remainder will be 0. So if the remainder is 0, then we know it divided by this value perfectly. And you can check if something is divisible by 2 by doing this. Basically trying to divide it by 2 and seeing if there's any remainder. If there isn't any remainder, you know it's divisible by 2. But I'll skip over that for now. And the final one's the brackets. Now brackets we've already gone over. If I do plus remainder and then plus result, you'll see something interesting. The remainder will be 0, and the result, as it was over here, will be 2. But it won't be 0 plus 2, it will just put a 0, no space, and then a 2, because we haven't added a space. If you want to add a space, you can do it like this. And then we have a space. 0 space 2. Now the reason why I didn't add them together is because it treats it like a string, because string is a dominant data type that we're using here. It's the one being used here. And remember, everything needs to be converted to the same data type when working with a certain expression. So the best way of making sure that the data type doesn't get converted into that, you can always just put these data types inside their own brackets. And then this will be calculated before it's converted into a string. And in this case it will say 2 at the end over here, which is wrong for this calculation, but that's what it's going to say. Okay, next I want to go over other simple stuff like x plus equals to something. So for example, instead of saying x equals to x plus 2, you could also say x plus equals 2, which will basically say take x, plus it by 2, and save it into x, which is the same as take x, plus it by 2, and put it back into x. So these two are the same thing. This is just a shorthand way of saying this. Of course, this won't work if you're doing this, because that's no longer the same statement, because now you're adding y and not x. But that's how it kind of works. Another option is if you're adding 1, like for example x plus equals 1, you could just as easily give the easier form, which is x plus plus. And plus plus is a really shorthand way of saying plus equals 1, or x equals x plus 1. Let me just write that out for you so you can see how long and unnecessary that part of code is. That can be shortened to this by the same rule as this, but since this is a 1 and we're adding a 1 to it, we can also just shorten it to plus plus. Same goes with minusing. Those are all the same thing. So now we're going to add 3 over here. I'm not going to show the values of x because I can just show that's what it means. And if you want to play around with it, you can. This is how you output stuff onto terminal. Next, just remember that for every single one of these, you have a equal sign possibility of it, like this. So if you used to do x equals x times 2, or x times y, you can do x times equal y. Then x modulo equal y is the same thing. That also works. And a lot of the other ones as well, like x and equals x, XOR equals, like I showed from previous tutorials, but that's not really related right now. If you want to see those tutorials, you can go on to tutorial number 2, where I mention it, and click on the little annotation pop-up that shows up at around about minute 12 of the video, and then decide if you want to see those kinds of videos. Next, I need to show that there's 2 things to the plus plus and minus minus. There's a more complex way of using them. For example, if I set x equals to 3, just to reset the value of x, and then I say x plus plus, you obviously get x equals to 4 over here, which is why we can output it right out into there and say x equals, and then plus x there. Remember, the spaces don't matter, that's why I didn't put spaces over here. And then you can click run. It will say x equals to 4, which is the expected result. Now let's go into the little bit more complex stuff. This isn't very complex, this is just a little bit different from what you've seen so far. I'm going to put x plus plus right next to here. I'm going to put a little bit of space so you can see this x plus plus is separated from this plus, just so it's a little bit easier to read it. And now let's go ahead and run this. Now the expected result is obviously 4, but the actual result is 3. And the reason for that is because x plus plus adds 1 to it after this thing runs. So basically, if we run this over here with the value of x, then we'll get the value 4 right over there. But we won't get the value 4 over here yet, because this hasn't taken effect yet. If you wanted to take effect, what you could do is put a plus plus before the x, and then it will take effect straight away before it actually shows the value. If you don't know how to use them or don't understand them, you can just separate them into two lines. There's nothing wrong with that, but that's a possibility. Anyway, same thing with minus minus. If we put it before, you'll see 2 will be taken into effect straight away, and if we do it afterwards, the 2 will not be taken into effect straight away. It will be 3 first, and then it will show 2 after this has taken into effect. Now, just to show you that it's not because something hasn't happened afterwards, I'm going to put something at the end over here to show that it doesn't matter that this minus minus is last. It will still only take effect after the statement. Basically, what this minus minus after the x means is that once this line of code ran, this next line of code will be where x is minused by 1. Anyways, that's basically how plus plus and minus minus works. I'm going to delete all this because that's unnecessary for now, and we're going to go into the next part of the tutorial. I'm going to go over a little bit of revision for if statements, but instead of showing an if statement, I'm going to show a different idea that allows you to do an if statement on one single line. It's shorter, and even though it looks more complex, it can make it quicker to code as well. If you have a short if statement, preferably, because if you have a long one you shouldn't be doing this, what you can do, and I'm going to save it into Boolean so you can see the result of it. Boolean, in fact I'm actually going to set it into an integer. Int a equals, and then we do conditions over here. So I'm going to put a Boolean so we can set the condition directly. I'm going to set it to false over here right now, just to show what happens if it's not. If condition, and over here you can do what you did in the if statement. This is basically the brackets of an if statement, but without the word if before it. Next, instead of the brackets that you start an if statement with, you'll put a question mark. Now what happens here is, what happens if it's true, or what happens if it's false. And don't forget to finish it with a semicolon, like all other lines, except for these brackets, which you won't always have to, but you'll see later on when we have to. Anyways, the condition over here is false. So this part is, let's put a 1 over here and a 0 over here. Right? I'm going to then output value of a, and you can see the value of a will be 0. Why is a 0? Well, the condition checks if this condition between the blocks, which can be an integer check, you can use the less than, bigger than, equal to, not equal to, with a number and stuff like that, or whatever test you're doing over here, but I'm doing this to shorten it. And what happens is, after this question mark, the first part is what happens if this is true, and after the colon, this part over there, anything that happens over here is what happens if it's false. And these values are returned. So basically what happens now is we're going to take this, and then we're going to give this value if this is true, or this value if it's false. So now let's change this to true, and show you that 1 will be returned. Right there, A1. Versus the false, which was A0. You can also change this value to 34 or 43. And then check. And the value will be 43. Because this value is what happens if it's false, and this value is what happens if it's true. So that's a single line version of an if statement. It can be useful, but you're probably not going to end up using it very much. and makes the code a little bit more difficult to read for some beginners. Anyways, let's go into loops, the most important part of this tutorial. So we're going to start with a for loop. If you know how many times this thing needs to loop, like say you want to loop through an array, I'm going to create an array over here, int array, and I'm going to show you a different way of creating an array. I'm going to say int array b equals, and then I'm going to put in these curly brackets. And remember, over here you do need to, because this is part of a line and not an if statement or a for loop or whatever it is. Over here I'm going to put a bunch of numbers. Right, now we know how many times we want to loop through it. We want to loop the amount of items inside this B array. So let's start with a for loop. The for loop has 3 sections to it. It has the first section, which is the initialization. So you initialize a counter, int, and we usually call it I, but you can call it Z, you can call it X. Just make sure you don't call it B or A if you're trying to access these variables from within the loop, because these will clash, because they have the same name. So I'm going to call it I, and we usually call it I. And if we have a loop inside that loop, we call it J. Inside that one, we'll call it a K, and so on and so forth. So we'll start with an int I, and we'll set it equal to 0, because we want to start from index at position 0, which if you saw my first tutorial, you'll understand why we're using 0. So I'm not going to bother re-explaining it in this tutorial. Anyways, I less than, and now we're checking if it's less than the b dot length, and you'll see length without any brackets around it. It's not length, it's just length, the word length. Now I'll go ahead and say I++. Now I++, as I've shown previously, is an increment. We can add 1. The reason why we're putting an I++ is this is what happens after the for loop ends and jumps back over here to reevaluate the condition. I is plus by 1, and then the condition is reevaluated. So in this condition, it really doesn't matter if you do plus plus I or I++. So there it really doesn't matter. Anyways, remember to close your brackets. And what you've got now is an I equals to 0, which is our index. I is less than b dot length, which is our length of the array, and I++. Now what we want to do is we want to go ahead and output the value. Put a b at position I. So you see, unlike the previous tutorial where we say at position 0, or at position 1, or at position 2, we're going to put at position I, and we're going to use the value of I as the position. So it's going to start from 0, it's going to run the first time, it's going to say 0, so it's going to be b at position 0, which is 1. Then it's going to go ahead and reach this. Then it does I++ and runs back here. Is I less than b dot length? Well, length of b is 1, 2, 3, 4, 5, 6. Okay, so length of b is 6. Is 1 less than 6? Yes, it is. So we're going to loop again, and this time I will be equal to 1. So we'll output at position 1, which is 3, and then we reach this bracket again. After this bracket, this evaluates again, so I++, which means I is now equal to 2, and then it jumps back here, and it checks. Is 2 less than 6? Yes, and so on and so forth, and it keeps running until the condition is false. The reason why we're doing less than is because we're starting to count from 0, and b dot length is human counting, so 1, 2, 3, 4, 5, and 6. But in machine counting, this is 5, this is 4, this is 3, this is 2, this is 1, and that's 0. Which is why we don't want to have 6, because there's no 6. So we want to reach up to the point where the number is equal to 5. So you can easily just do less than or equal to b dot length minus 1, which would then be 5. and then we can loop up to 5, with the last index being 5, which is this one, which would then not be a problem. But it's easier, and easier for the computer as well, to just say less than b.length. Of course, since computers today are so quick, if you find it easier to say less than or equal to b.length minus 1, then you can do that, but just remember to put the equal to, less than or equal to. But if you're doing it like this, make sure you don't have that equal to, unless you're doing something else that needs that equal to, because of some other thing that you're doing. Anyways, now we're outputting all the values over here, so if we run this thing, you'll see the numbers will be placed here, 1, 3, 6, 3, 5, and 2, which are all the numbers we've got from this array, which is neat. So now we've got a loop that checks how long this is, and then loops that many times. So if we add more elements to this, we won't need to change the loop over here. For example, if you were to put a 7 right here, which is 1, 2, 3, 4, 5, 6, 7. So this is the 6th position, and this is position 0, right? But if we were to say this is 7 in length, which is true for this condition, but what happens when later on we want to add another number? We want it to be an 8 length, and we have a whole bunch of for loops down all the way to the bottom of the code. You don't want to go through every single one and say 8. So instead what we do is we check the length of b, so we don't have to change it if we change the code up here. So we can change it in one place and then not have to repeat ourselves. dry. That's what it means. Basically, if you can do something without repeating yourself, that's how you should be doing it. Although there are some ways where you can not repeat yourself and still be doing things wrong, so that's not necessarily a good way to check if your code works. It's just to say if your code repeats itself, you're doing something wrong in some place. But if your code repeats itself in one line, like something like this, repeats itself at some other point in time, like over here, then that doesn't count, because that's just one line of code. But we'll get to that later. Anyways, now we've got another kind of loop called a while loop. This is called a for loop. And a while loop is a loop that's basically going to happen whilst something is. So we're going to start a number, but for while loops you don't always have a counter. I'm going to call it count equals 0, and say while count is less than b dot length. Anyways, if you do count is less than b dot length, so it will keep on happening like a for loop until this condition is met, or in this case, this condition is met. But unlike a for loop, there is no auto increment like this over here. It doesn't automatically increment it for you when you say I++ over here. It won't do it when it reaches this last bracket. That part is left up to you. You're going to have to be the one that says count++. And if you forget to do that, then you'll end up in what is called an infinite loop. Now this is not a good use of a while loop, because in a while loop you generally, if you know how many times you're going to loop, then you should actually be using a for loop and not a while loop. But there may be conditions here where you're asking the user for some input and then keep looping until the user has inputted some kind of value that you want, or some condition happens, like some time that is reached. Or if you're counting prime numbers or any kind of things like that, and you don't know when the next prime number is, but you want to find 5 prime numbers, then that's basically how you do it, and then you only count ++ when you reach the next prime number, or something of the sorts. Anyways, for that kind of case, you'd want to create another variable, like, I'm calling it j even though it doesn't collide with I, just because I don't want to have to worry about doing the for loop later. Anyways, so basically like that, and then inside here you'd use j for some purpose. I don't know what purpose, but some purpose. Anyway, this condition happens, and whilst it happens, you do that. Next, we've got a enhanced for loop. I'm going to go back to here and show something else. So this is a great structure to loop through an array, but there are a few other ways of looping through an array. While loop is the bad example of looping through an array, because you should actually be using a for loop. But there's another for loop that can be used specifically for looping through an array when you don't need to know what the index is. In other words, when you don't need to know what I is for some calculation, then you can do this. It's called the enhanced for loop. And the purpose of it is to make your life easier. Even though some people may find the idea of it a little bit difficult at first. So what you do is you take int and you create a temporary int value, like I, for example, int I. But instead of saying equals to 0, we let Java decide what it will equal to. And what we do now is we say b. We put b over here. Since b is an array, as you can see, an array of integers, each and every element here is an integer, because we've put an integer array. And therefore all the elements inside of it are integers. So you could just take an integer as a holding cell, and then use that to hold the value of each and every element in every position as you go through the loop. What happens now is it will basically loop through the entire array, and every single element in the array it will save into I. So instead of saying b at position I, you will now simply just use the value of I, which is why you can do this. And this, as you can see, we've said b at position I over here, but I over here. These two are equivalent to each other. And remember, that's a colon to say in. That colon simply means in. So if you were to say in English, if you were to write pseudocode, you'd say integer I in array b, or integer array, which is what the English form of it would be. And this is what it would look like in code. The word in simply gets replaced by that, and then for, you can think of it as like while, for each. Basically the wording for this, if you want to say it in English, the easy way of saying it would be for each, unlike this previous for loop, which is just a for. This one's a for each element in integer array b, save into I, and then over here output I, which is going to be the values as it goes through the array. Now, because of the structure, instead of I equaling to the index, I will now equal to the value, which means you won't be able to check what the index is at that position. So if you need the index for some reason, then you're better off using this instead of this, which is why they are both in the language. Anyways, I'm now going to output the value, and you'll see the values over here that don't really matter. Ignore anything from here downwards, that's this while loop running, and only take these values from here all the way down to here. So 1, 1, 3, 6, 3, 5, 2, 1, and 3. So instead of having to do it like this, which outputs the same thing, you'll rather do it in the enhanced for loop and shorten it to this. And this is useful when you don't actually need to know the index, like this position. For example, you might need to know this position, if you're using it for something else as well. So if you're using it for something else, then this is the obviously better way of doing it. Anyways, next thing we're doing is called a do-while loop, and it's basically the least used form of loop, but it's useful. And you're basically going to end it with this right here. Unlike the rest of them, a do-while loop actually ends in a semicolon. And this while loop is after the ending brace over here, with the brackets right there, and that's where you write the condition itself. Now, we've already done count plus plus, and since count is a variable that's inside these and not inside any sub block, this variable is visible over here. But because of this condition, we've already established that by the time this while loop stops, this while loop should not happen. But a do while loop is a little bit different. It will at least do the condition once. And I'm simply going to put a little output. I'm going to put this output over here just so I can put a space between them. You can put an empty thing like this to put a blank space in between. This is like enter key, effectively, in the code. And if you system out the print line, I'm going to out count. And just to show that it's not less than, I'm going to show this value. And obviously this will not make any sense when you see it. But you'll see it will run at least once, even though this condition obviously will not or should not happen. So you can see it ran once and then it stopped. So the reason for that is a do while loop basically says do this at least once, and then if the condition is true, then repeat until the condition is false. So this is useful if you want to get user input at the very beginning of a program and then run until the user input is something. But you could also use a while loop and just put the user input before the while loop. Same thing, really. Anyways, there's a few ways you can actually code that allow you to break and all kinds of things like that. So as I've shown in the previous tutorial, there is such a thing as nesting with loops as well. You can put a loop inside a loop, and if you have a use for it, that can actually be useful if you need it for something. So with a for loop is what I'm going to do right now. In I equals 0, and then I'll put I is less than 10, I plus plus. Alright. So now we're going to output the value of I. And it has nothing to do with this, since we're not actually using this or using this. So basically it's just an I. It has nothing to do with the array B, and it won't affect it in any way. So there's a way to end a loop. For example, if you wanted to do this for some reason, you output it, and if I is bigger than 5, then you want to stop the loop. Notice the break statement that we used in the switch case. This basically says break out of this for loop. And it's the most inner for loop that it will break out of. In other words, if there's a for loop out here, it will only break from this for loop and not from the outer for loop. So if there's a for loop there and it's holding this thing, let's just say that there is something here. And then basically what happens is if you say if I is bigger than 5, then break, what it will do is we'll take this for loop and it will break out of it. So it will jump there and it will stop executing and it will run anything that happens over here, which is something that won't happen under a normal circumstance. In a normal for loop, it reaches over here and then it does the increment and then jumps right back over here. But if you do a break, it stops this entire for loop, kills it and makes it stop completely, and then continues the code. But if you wanted to break out of this external for loop, you could do something called a label. And you can name your label whatever you want. You can name it, I don't know, I'll just put my YouTube username. Anyways, so basically you put this label and you call it whatever you want, but I believe it's the same thing as a variable. You cannot start with a number, as far as I know. But the idea is basically like this. You can actually break, and if you say break, you'll break out of this internal for loop. But what if you wanted to break out of this entire for loop without having to worry about breaking here and then breaking again over here? Because you've got some code that happens here, but you don't want it to happen. So what you could do is you could say break, and then put the name of your label, which is the same as over here. I'm just going to put some random, and I'm going to indent the thing. So you can see this whole thing takes this for loop from here to here. Now, if it's difficult for you to read it like this, you can always just do it like this, but make sure to close your bracket. So you can always just do it like that. There's no problem with that either. So basically what happens is you go and you break out of this. So you go right to the end of over here, and then you continue your code over here. You can also put the code over here, and it will continue over here. So I'm just basically saying is it will jump to over here, and then we'll start running anything afterwards. Anyways, that's one useful use case of this kind of thing. But what if you wanted to do instead of a break, just simply skip over this iteration and add 1 to I. So I still want to add 1 to I, but I don't want to run anything that happens over here, basically. So I don't want this code to run, but I still want this for loop to continue. So what you can do is you can do this. You can write continue and then remove the label like that. And what will happen is it will now skip over one iteration of this, do an I++, and then retest this condition and run the rest of it. Since we're testing if I is bigger than 5, then every time it's bigger than 5, it's going to skip the rest of this code over here, which usually you don't want to do a break or a continue, unless you're doing it in a switch, in which case you kind of have to. But generally, break and continue is not good code practice, so you don't really want to use a break or a continue. So I'm just teaching this for knowledge and not for actual usage. So actually, when you're doing a label, don't put brackets around it, because that's kind of breaking the whole thing. Basically, when you put brackets around it, it thinks that these brackets are what you're trying to label and not this for loop. So rather just not put it there, so you can label this for loop. Then you can just say continue and your label name. And then instead of continuing with this one by just skipping the rest of the code, reevaluating after the I++, and then doing that, and then testing, and then running it again. And if it reaches a continue, it once again skips the code, does an I++, and tests this again. So if you do a continue with the outer loop like this, and you label the outer loop, you will, instead of skipping this, the rest of the code over here, you'll skip the rest of the code over here and over here. And you'll basically be jumping from here. You'll do a continue, you'll jump over here. You'll do y++, which is what we have over here. And then go all the way back here. Do y is less than 0. And if it is, then continue. So that's what this continue will mean, basically. But those are all discouraged ways of doing this. So please avoid these as much as possible. And good luck for the rest of your coding. Now the next tutorial, I'm going to go over methods. And I'll explain about those in the next tutorial. So stick around for those, and like and comment if you enjoy this, so I know if I need to continue, because I've seen a few people have been watching, but No one's really been leaving any kind of likes or comments or anything, so I'm not sure if people like it, if people are getting confused. So see you in the next tutorial, and that's it for this tutorial.